and welcome to the demo on SpectrumWorks, an Android app developed at the Spectrumlab Indian Institute of Science, Bangalore. So I am going to demonstrate you the app facilities. Let us first have a look at the UI. This is the user interface. As you can see, there are two modes: image mode, camera mode, and you have the settings menu here. In the image mode, you can actually process images directly by loading on from the SD card. I'll show you one of facilities. As you click, you will be given a menu from where you can load a given image, and then using this option you can apply any of the filters available. I will explain you about the filters in the camera mode. So, for example, if you have applied a bilateral filter on the image, it's possible to apply more operations over the bilateral filter image. For example, edge detection over the bilaterally filtered image, and after that you can further blur that input. This So, in this way you can actually process inputs in a cascaded manner. Now, coming to the camera mode. In the camera mode, as you can see, there is a live feed that you can process using the facilities in the app. To get the menu, you have to press the options button on the top right corner. After pressing the button, you can see a list of possible filters that can be applied over the frame. This is, for example, you can actually go to the settings also from here, which will reveal all the filter facilities to you. For example, the bilateral filter or the wavelet based denoiser, which has been developed at the Spectrum Lab, and stuff like that. So, we'll see whole filters one by one. So, here is what the app does basically. So, it has a camera feed, and it has basically noise removal filters called denoising filters. We have edge detection filters for detection of edges, and object detection, which is right now constrained only to detection of circles using Huff transform. The app basically uses OpenCV to render and process at its backend. But we also have implemented our own Java codes for the algorithms which we have developed in our lab. So, let's start with the image denoising. In order to demonstrate the image denoising performance, it is important to have noise, but noise usually occurs when there is low light, or that's called a Poisson distributed noise, or in some other scenarios where the sensor is not of very high quality. So, it's very easy to observe grainy pixels which are classified as noise, which is particularly random as opposed to the content of the image. So, we will simulate here noise by pressing add noise. This actually lets you add noise and see the performance of various denoising algorithm. Very basic approach to denoising would be to blurring or smoothing of the incoming frame. If you choose that option, blur image, you can see that the noise is actually suppressed, but the image content is completely blurred. We don't want this. Certainly we want that the image content should also remain preserved. For that, very well known bilinear filter, bilateral filter is available, and we have implemented it on this app. So, let's see what is the performance of bilateral filter. Now, as you can see, the bilateral filter does a pretty good job, that it preserves the edges, whereas it suppresses the noise. You can hardly observe any noise now in the incoming frames, but as you can see, the insides of the regions between the edges, it also has gotten very smooth. For example, now if you look at the board, that pattern is visible nicely, but at the same time there is still some noise left at the inside regions. To remedy this, we have developed one of the most effective denoising techniques, which is based on a wavelet-based decomposition, and based on that, subband regression. So this is particularly effective because it does not assume any distribution of noise, and although it works only on grayscale images and on the square frames. So now I have applied this, and as you can see, this technique gives you the denoised result, and although this is a black and white frame, it's easy to extend it to the color. We'll be implementing it soon in the next features. Now you can see, as compared to the bilateral filter, the inside regions which are there, they also don't suffer the loss of texture. So this is one particularly important feature. So this is one of the denoising technique developed at SpectrumLab. It's called the risk minimization based wavelet denoising, agnostic to distribution of noise. Now going ahead with the image edge detection, all of us know that what is canny edge detection. It is one of the most primitive methods of detecting edges in images. So it is available in this app. We will apply and you see that we can directly see the edges. The parameters have been tuned, which can be set according to the convenience. As you can see, the canny edge does a pretty good job of detecting edges, but at the same time, if we have to see how it performs in the presence of noise, so we will just add noise, and as soon as we add noise, we see that the performance of canny edge really degrades by a very large amount. No more we can see edges, very sharp edges and stuff like that in the frames. So we need a robust method to solve this. Another very famous edge detection technique is Laplacian of Gaussian technique, that is Laplacian of Gaussian filter. Now if I record the edges in this filter, again I see that the corruption due to noise really affects the kind of edges, although it performs better than the canny edge detection technique. Another technique that we have developed recently in our lab is called a bilateral steerable edge detector, and it is far more robust than the previously two demonstrated techniques. Now I will just demonstrate you. Okay. So as you can observe, the edges which are there are not affected much by the presence of noise. Yeah. So these edges clearly, as you can see, and now I will demonstrate the same over one of the flower inputs that I have. There is a picture on my laptop which I am pointing it at. You can see not only that it is robust against noise, but also given any orientation of the image, the edge trend won't suffer. So it is optimally oriented, and the rotation of the object will not change the strength of the object. This is one of a good feature that we want to have in any edge detection algorithm. Moving on to the detection of objects, right now we have only implemented Hughes transform for detection of circles. So let me switch to that, and let's disable noise. Yeah, now you can see it's actually detecting a lot of circles. There are a lot of false circles. So we'll just go to settings, and through the settings we have all the options to change the circle radius, circle upper, the canny upper threshold, maximum circle radius and stuff like that. You can actually increase the threshold so that it does not give a lot of false circles. Now we'll try to detect, and as you can see, the detection is near perfect, and we are able to localize the outer circle. Due to reflection, the inner circle part is actually lost a bit. Just to give another input, so in this frame also you can see the circle, the eye of the minion is clearly pointed at. Yes. So so we can see that this is just a basic object detection technique, but we can build on far more sophisticated techniques such as gradient vector flow and very different type of techniques, but the computational power required will be of similar order. That's the idea here. We can also implement generalized Huff transform for detection of general shapes which are not ellipses or circles or of any particular shape. So as you can see, this app covers all the three areas of image processing, not all the three, but the main basic three areas such as image enhancement, image restoration, edge detection, that is feature detection, and finally feature recognition such as the circle detection. But this is just in a very nascent stage where we plan to develop it to a later advanced stage where we will integrate far more sophisticated enhancement, detection and recognition algorithms so that it can be used for educational purposes at various universities or it can be used by user to integrate their own algorithms into the app. This will be of great help if the university professors or somebody who is trying to understand the image processing stuff uses it for practical purposes. That's the idea behind the app. Thank you.